First of all, I want to thank everybody for taking time out of their busy schedules to partake in this webinar. Over the years, we've had some very, very, very good feedback from it. One of the big comments that I get usually revolves around the fact that, man, that was a lot of very technical information. And what we'll typically see is that people will come back and actually view the webinar multiple times to get either clarification on points or to glean additional information. One thing I will say is that for those of you who either deal on the designer / specification side of the business, whether it's architects or construction specifiers or even general contractors, there actually is a webinar that can be viewed. It has a lot of the same information, not all of it, but it can actually be viewed on demand. So you have the ability to either forward it on to somebody, or if you want to try to go back and actually glean this additional information based off the on-demand video, you can definitely do that. The website for that is aiaspec.com. Again, if you are dealing with architects or specifiers, they do have the ability, if they are members of AIA, they have the ability to get LU credit for continuing education. So, for those of you who don't know me, my name is Jason Spangler. I'm the flooring division manager here at Wagner Meters. I'm responsible for not only the rapid RH and the concrete side of moisture testing when it comes to flooring, but I'm also responsible for the small line of hand meters that we have that are utilized to test the moisture of subfloor and finished wood flooring products prior to installation. We are going to do a Q&A. I'll get to as many of the questions as I can. So please, as you think of them, please type them in. If for whatever reason, because I know there is a lag sometimes between when we finish this and when people are actually hearing it, I do monitor the emails that come in as far as Q&As. So if for some reason I am gone prior to the answers being done for you, I will respond via email. If down the road you come up with questions that you need help on, please don't hesitate to call us directly. My phone number is 800-634-9961, and my direct extension is 235. So without any further ado, we'll get on to the questions. Looks like we have one here from Craig. It says, if you walk into a commercial store remodel with an old slab and no vapor retarder, then see several utility trenches open, should you test? So I guess we can look at technical versus real world, if you want to call it that. I mean, really, if you get down to it technically, most people, if you were to ask them, if you know for a fact, and when I say if you were to ask them, if you were to ask a manufacturer, whether it's a flooring manufacturer, adhesive manufacturer, I don't want to speak for them, but I'm just putting the information out there, that if you know for a fact that there is not an intact vapor retarder underneath the slab, you really have two options when it comes to concrete and putting a finish on it. You either need to have an intact, effective vapor retarder underneath the slab directly, or you need to have an effective, intact vapor retarder on top of the slab. One way or another, you need to have a vapor retarder so that you can mitigate the potential of high moisture levels spiking because of various conditions that may cause that. So if you walk into a job and you know for a fact there's no vapor retarder, there's going to be some people that are going to say, the point of moisture testing really is moot. Don't even worry about it. You just need to go in there and bid and install a moisture mitigation product on top of that slab that will do 100% relative humidity. So you're looking at, two-part epoxy systems, depending on the type of flooring that you're talking about putting it on top of it. But you're looking at basically a bulletproof moisture mitigation product on top of that slab that effectively acts as that vapor retarder. Now, does that mean that I don't have people that maybe question whether or not, but they don't have the ability to 100% validate whether they have an intact vapor retarder? I have people that do remodels all the time that are older slabs, and there's probably a potential that there isn't a vapor retarder, but they do moisture test. They're working with kind of what they have to work with. You walking in with utility trenches, being able to verify that, there's probably a good chance a lot of people, it's probably some still would, but probably a good chance that a lot of people wouldn't test in that situation. Just looking at doing something from a mitigation on top of it because they know for a fact with that open slab that there isn't a vapor retarder. Looks like we have one from Mark. Temperature was mentioned as an important part of a moisture reading, but nothing was said about ambient versus slab temperature measurements. Or I'm sorry, slab versus ambient versus slab temperature relationship. What temp reading is important during RH testing? Well, the one thing I find out, Mark, and how you doing, buddy? The one thing I find is that if you have, because the standard does say that you have to have ambient conditions that are at service conditions. Service conditions meaning that if you were to walk into this Main Street commercial project that had customers coming in and out of it, and you had a device for testing the ambient relative humidity and temperature, you could measure that. That's your service conditions. So then if you walked into an area that hadn't been built out yet, knowing whether you were within proper protocol for testing would mimic closely to what that storefront was that was completely open and functioning. That's what the definition pretty much of service conditions is. If you have a space that is at service conditions for a duration of time, again, it's going to be different for different areas, but at various times, the concrete has a certain amount of insulatory capacity to it. So what happens is you end up with a situation where if you're 70 degrees in the air, if it's there for a reasonable amount of time, you're going to find that that concrete, surface or otherwise, is going to be very close to what that was. That's why I have a lot of times when people call me up and they'll say, hey, I have really high, relative humidity readings. Well, I'm not just going to start giving input based on the high relative humidity readings. I'm going to start asking about what are the ambient conditions, and then I'm going to look at those ambient temperatures and ambient relative humidities and compare them to the concrete. So, for instance, if I have a situation where I have 58 degrees in the concrete with the probe in the concrete, I feel pretty comfortable with my experience knowing that those ambient conditions were fairly close to that over the long haul. So if somebody tells me that they were actually at service conditions, which usually most people are going to say is 68 to 72 degrees, I know something's not right. Either those conditions were just brought to that point before the testing person came on the job site. I've had situations where somebody will go out there Friday morning and they'll put the stuff up there, Friday, and they'll put the stuff in there. They'll test the ambient conditions. They're at service conditions. General contractor swears up and down that they're going to leave the building up and going during the testing period for the weekend. Unfortunately, as the last person leaves the job site, all the heat, HVAC, temporary or otherwise, goes off. Everything cools down over the weekend. First thing Monday morning, somebody fires everything back up again. All the trades are back on the job. Flooring contractor comes on the job. Everything's good by that point. And so there's nothing that we sit there and actually question whether those conditions were, appropriate. But you can see it, that the temperature in the concrete will tell the story as far as what the conditions have been like over the long haul in the air. So to answer your question is the temp reading for both is important because they will help you tell the story of whether or not the conditions were appropriate to meet that ASTM standard. Hope that helps. So some of the other questions I come up with, we talk about depth-specific measurements all the time because relative humidity really is a depth-specific measurement. It is critical to know the thickness. Obviously, there's only a certain amount that you can do. There's a few different ways that you can find out the thicknesses. You can look at it from a technical standpoint. You can look at possibly old construction documents if you're talking renovations. You can look at the first question that we had about trenching for utilities. Sometimes when you go on a job site, you're able to see that the trenches are open because they're actually moving plumbing or electricity. You have the ability then to see what the thickness of the concrete is. I always tell people that as you do relative humidity more and more, and you actually have it in your head that you need to know that, the thickness, it's amazing how many different tells there are when you walk onto a job site, because now you're hypersensitive to knowing, to needing to know that. Elevated slabs. There's sometimes when you're in stairwells walking up to the second floor, third floor, whatever, where there's going to be some kind of either venting or plumbing or going, penetrations going through the upper floor. Well, those penetrations aren't, the holes cut through the floor aren't exact. They're usually quite a bit bigger than what the actual pipe is. So you can see, varying thicknesses that you have there. They also make a device for testing the thickness of the concrete. It's an electronic device. Works off of something called echo impact, and it's basically it sends a signal through the concrete. The signal comes back to the device that's placed on the surface, and it gives you a close approximation of what the thickness of the slab is. Great in concept. To justify it, most people have to do a ton of moisture testing because the device is about $2,500 last time I checked. And so for most people, it tends to be kind of outside the realm of reality. Last but not least, you see people that will take a smaller diameter drill bit and they'll drill all the way through the slab in a couple of key places. Take a piece of wire, you can make a J-hook out of it, so it's got a little bit of spring in it. And as you push it down, it'll compress the J a little bit. You push it down all the way. When it gets through the bottom of the slab, the J kind of pops out so that when you pull it up, you can feel tension on the bottom of it. Once you feel that tension, you can mark a Sharpie at the top, pull it out. You can see where the radius on the J-hook was versus the Sharpie mark. And again, it gives you a close approximation. And it allows you, if you do it in a couple of spots, it allows you to compare to make sure that during the process of pouring the concrete, there isn't some drastic deviation between different areas of the building. If that's the worst thing that ever happens to a vapor retarder, that possibly you go all the way through it and make a hole in it, I would say that most people would probably say that's a pretty good installation. Vapor retarders, a lot of times, depending on thicknesses, can have minor imperfections in them as they're being poured, or major imperfections, but they can have issues. So a couple of smaller holes through there is not going to be a make or break. You can go through and refill those holes with like an epoxy or some kind of injectable that will cover those holes up. When you're talking elevated slabs, again, you have that device on the surface that will be able to show you where the highs and the lows are. What we find is that we have people that will either take a smaller diameter drill bit and they will try to get themselves visually, whether they look at it from the floor below and look up and kind of get a rough idea of what the on centering is for the metal pan decking, so that they can go and they'll drill smaller diameter holes to try to get a pinpoint of where that deepest section in that pan decking is. And then they'll measure accordingly to get that on center, because what we recommend is that you identify where the deepest section of the pan decking is and then calculate with that thickness 40% and drill in that thickest section. The other way that we find people doing it is that there is a couple of different metal detectors out there that they function much like wood stud finders in a wall, and they look a lot like the same. They scan through the surface of the concrete, but they don't scan too far, so that they'll pick up where the high parts of the metal pan decking are, but they aren't so strong that they'll pick up where the deeper sections are. So they'll scan across, pick up the high section, scan across a little bit more, pick up the other high section, and between those two, they know is where the deeper section is. So, those are a couple of ways. None of them are perfect, but there are a couple of ways that I've heard that people are doing stuff out in the field. So it doesn't look like I have any other questions. Again, if you think of anything else, definitely type it in. I monitor this for a while. Or if you have any questions where you want to speak with me specifically, you can get a hold of me at 800-634-9961, extension 235. Thanks and have a great day.